So we've got the section on trig, right angle triangles, a section on circles, a section on time, and a section on metric to imperial units. You might have other things you want to remember quickly that you want to jot down. It might be what a box and whisker diagram looks like. Box and whisker diagram, which is coming up in this test, just to remind yourself as you sit down quickly, it's got a minimum value, a maximum value. The lower quartile is the bottom end of the box. The upper quartile is the top end of the box, and the line in the middle is the median. So you might want to jot that down. There might be other things. That's for you to do. Whatever you write on that sheet is for your help. Okay? So if you end up watching any of my walking, talking mock videos from last year, you will see that every time we start one of these, that's the very first thing we do, is get out of our brain all the things we might need to refer to. Are there any questions on that? Are we ready to go? Okay. Question 1. The following two pieces of information, given in both kilograms and pounds, were seen in a cookery magazine. So use 5 kilograms, and then they're telling us what it is in pounds of apples. Wash and peel them. Use 2 pounds of sugar, and telling us what it is in kilograms. Warm the sugar before use. Here's the question. Now what I try to encourage you to do is, wherever you get a question, you highlight what that question is, so that when you think you finished your answer, you go back and say, have I answered that question? So use the information to draw a conversion graph between kilograms and pounds. We've practiced conversion graphs quite a lot over this term. They've come up in pretty much every progress check that we've done. If you look at what we have here, we've got a partially filled graph. The kilograms axis has been filled in, 0, 1, 2, 3, 4, 5, 6, 7, but the pounds axis hasn't. So the first thing we have to decide is what the scale is that we're going to use on this vertical axis. Okay? And whenever you're deciding on a scale, you want to use as much of the axis or as much of the graph as possible. So if I'm going to 11 pounds and 2 pounds, the biggest value I need to put on is 11 pounds. I'm not going to go up 10, 20, 30, 40, 50, 60, 70, because all my information is just going to be in this part of the graph. Can I go up in ones? 1, 2, 3, 4, 5, 6, 7. No. So I'm going to go up in twos. So that would be 2, 4, 6, 8, 10, 12, and 14. Now, at GCSE in the intermediate tier, all our conversion graphs are going to be straight lines. Okay? And in order to draw a straight line, you need to have at least 2 points. And they're giving me 2 pieces of information. They're telling me that 5 kilograms is equivalent to 11 pounds. So on my graph, I can go across the bottom to 5 kilograms, and then I need to go up to 11 pounds and put a cross. And don't do a tiny little dot. Make it clear to the person who's marking it that that cross is there. So I've used that bit of information. So I put a tick there, I've dealt with that. Second bit, use 2 pounds. So 2 pounds is on this axis. So I'm going up to 2 and across to 0.9. So I've got to make sure now I know what each little square on this axis is giving me. So it's going up from 0 to 1 in 10 jumps. So that's going to be 0.1 each time. So the point is going to be vertical to 2 and across to 0.9. And regardless of what units you use, nothing, 0, is the same in both. If you've got 0 weight, doesn't matter what you're weighing it in. So the other point you could have plotted there is on 0, 0. You're then going to get your ruler, and you know you're going to get it right if those points lie in a straight line, which they do. So draw your line then right the way through the graph like that. Okay? So there's 3 marks for that. When we finish the whole question, I'll tell you how those marks are awarded. We then move to part B. A person weighs 10 stone. Use your graph to estimate the weight of this person in kilograms. That's the question, that's the command, that's what they're asking you to do. Okay? Remember to show the method you have used. So if we look back at the graph, I want to find out what 10 stone weighs. Well, the graph only actually goes up to 1 stone, because 1 stone is 14 pounds. So this is a really common question, where they ask you then to use the graph to find something that you can't just read off the graph. So I know that 1 stone equals 14 pounds. And I can read that off the graph, because 14 pounds, if I read across to the graph, and it's always a good idea, I talk about this a lot, that whenever you're reading off a graph, to draw on the graph to show what you're doing. So I'm reading from 14 in this direction down. And you need to be as accurate as you possibly can. Okay, so don't be slapdash. Make sure you're being careful with your lines. So this I'm reading off as 6.123. Okay, you might have 6.4. That would be fine. So coming back to the question then. 1 stone is 14 pound, and 14 pound is 6.3 kilograms. So 1 stone is going to be 6.3 kilograms. So to find 10 stone, I need 10 times as much. So I need to multiply that by 10. Now, on a paper 1, in many subjects talk about starting GCSE in year 9 or starting GCSE in year 10. In maths, you started GCSE in primary school. A lot of the skills you learned in primary school, in particular about non-calculator methods for adding, subtracting, multiplying and dividing, you first met in primary school. And here we are in year 11 GCSE being tested on those skills. Okay, so don't just think when you're practicing you're only looking at work from September of year 11. It's all of the skills you've gained right the way from primary school. So 6.3 times 10, hopefully you're happy that that's going to be 63 kilograms. So overall there are 6 marks for that question. So let me show you where those 6 marks are allocated. If we go back to the graph, There's 1 mark. It's a B mark. Now, B marks are what the examiner is just looking for. If the examiner sees it, doesn't matter if you're on a method, you're going to get that mark. So there's a B mark for the scale you use on this axis. So if you've decided to go up in 10s, you're not going to get that mark. If you're going to go up in 2s, you are. There's a P mark for plotting the points. So I've plotted 3 points. Any 2 correct will get you that P mark. And then there's an L mark for drawing the line correctly. Now, if your points are wrong, but you've drawn a line through them, you might lose the plotting point, but still get the mark for the line. So the 3 marks for that, if you see a graph and you see 3 marks, one of them will be for choosing the scale, one of them will be for plotting the points, and one of them will be for accurately drawing the line. When we come to part B, there's a B mark on part B, and that is for reading off your graph 14 pounds is 6.3 kilos, or a similar. So that's for reading graph. Then there's a method mark for timesing by 10, and an answer mark for 63 kilograms, or for timesing whatever you've read by 10. So if you've misread the graph, you can still get 2 out of the 3 marks for timesing by 10. So that's question 1. If during this you don't have time to copy everything down, remember it is being recorded and you will be able to go back at it over the weekend at home. You take your papers home and finish off what you're missing. So don't panic about writing everything down. It's probably more important that you're listening and watching what's taking place. So we're on to question 2. David has completed a 12-mile walk. David has drawn a graph of distance against time for the first stage of his journey. So you're seeing this and your brain is thinking distance time graphs. Okay, so you're filtering now, thinking, what do I need to know about distance time graphs? There's no question on there. So this is an annoying one where you're going to have to do a bit of flicking. So how far did David walk in the first hour? So that's a question. You probably don't need to highlight this because it's the only bit of words in the question, but that's what they're asking you to do. When you're working with graphs, it's really important that you deal with the scale. So on the time scale here, it's jumping from 10, 12, 14, 16. So we've got 2-hour jumps. Halfway in between there is going to be 11 o'clock, 1 o'clock, 3 o'clock, 5 o'clock. Between 10 o'clock and 11 o'clock there are 10 little squares. But between the 10 o'clock and 11 o'clock there are 60 minutes. So in this gap here we've got 60 minutes. So each little square, because there's 10 of them, is going to be 60 divided by 10 is 6 minutes. So each little square is a 6-minute gap, a 6-minute interval. And then it's a more straightforward scale on the vertical axis. So we'll talk about that if we need to. But the time one is really important, that you figure out each little square is 6 minutes. How far did David walk in the first hour? So the first hour starts at 10 until 11 o'clock, and then if you read up to the graph and across, once again there's a gap there from 4 to 6, which is 5. So in the first hour he walks 5 miles. It's not asking you to give the units, so if you just wrote 5 there, you'd get the mark. Only if they tell you to write the units is there a mark associated to it. Part B, David stopped for a rest. For how many minutes did he stop? So the question is that part. For how long did he stop? Well, the knowledge that you should have from distance time graphs is where he's not moving is where the graph is flat. So he stopped between that point and that point, which is between 11 and 11:30. The question is asking for how many minutes. So don't risk writing half an hour, because that's not in minutes. So he stopped for 30 minutes. Have I answered the question? Yes. Part C. Without calculating any speeds, explain how the graph shows that David walked more slowly after his rest. So this is another piece of knowledge that you should have from distance time graph, where speed changes by the steepness of the line. So between 10 and 11, it's quite a steep line, so he's traveling quite quickly. Between 11:30 and 1 o'clock, that line is less steep, so he's traveling less quickly. So what's the question bit here? The question bit is explain. Explain, so they want you to use words. How the graph shows that David walked more slowly after his rest. And all you need to put is something like, because the graph is less steep at this stage, or something like that. Okay, so because the graph is less steep at this stage. Have I answered the question? Yes, I've used words to explain. Part D. At 13 o'clock, 1300 hours, 1 o'clock, David stopped for lunch break for 1 hour. David then continued his walk at a constant speed. He completed his 12-mile walk at 16:12. Complete the graph of David's walk. So that's what we need to do. So we need to go back to the graph. And it's saying, at 13 o'clock, David stopped for lunch for 1 hour. We know that when he stops, it's going to be a flat line. So for 1 hour, it's going to take him from 13 to 14. So it's going to look like that. Look back to the question, have I used the information? Yes, I've done that bit. He stopped for a lunch break for 1 hour. He then continued his walk at a constant speed. He completed his 12-mile walk at 16:12. So on the graph, 12 miles is the top line of the paper, of the graph, and at 16:12 he's going to reach that line. Now we've already worked out that each little square is 6 minutes. 16 is here, which is that point, and then 12 minutes will be 2 little squares beyond it, because each little square we know is 12 minutes. Okay, so let's see how this question is marked. So if we go to part A is only worth 1 mark So they're looking for the number 5. If they see it, you get a B mark. If they don't see it, you don't get a mark. Similarly for part B, we're looking for 30. If we don't see it, you don't get the mark. Part C is an E mark. They're looking for you to explain what they're asking you to explain, but it's just 1 mark. And then for part D, there are 3 marks. The 3 marks are awarded on the graph. There's 1 mark for this flat bit. There's 1 mark for this point at distance of 12 and time of 1612, and there's 1 mark if you've joined them together. So 6 marks for that question. 3 of them for what you've drawn on the graph, and 3 of them for what you're reading. Okay, we're moving on. Question 3. During the first week of January, Toby recorded the midday temperature in his back garden. He discovered that over the 7 days, one day the temperature was 5 degrees. The minimum temperature was -2 degrees. The range was 12 degrees, median was 4, and the mode was 2. So as you're reading that, you're immediately thinking of averages. If the mean temperature for the week was 4 degrees, what were the temperatures for each day? So there's the question part. What were the temperatures for each day? Now, where you have to be clear here is we've got 7 days. So I'm going to put 7 lines on my page. 1, 2, 3, 4, 5, 6, 7. I need to put a number on each of those. But when we're working with averages and means and modes and medians, it's most helpful if those are in order of size, not order of days of the week. So that's not going to be Sunday, Monday, Tuesday, Wednesday. That's going to be smallest to largest. And then we see what information we can plonk into those boxes that we've created. So one day the temperature was 5 degrees. Well, I can't use that yet because it could go anywhere. The minimum temperature was -2 degrees. Well, the minimum I know is going to go in that smallest box. So I can write that one in, and then I can put a little tick next to it so I know that I've used that piece of information. The next one, the range was 12, so the knowledge that you need to have is the range is the difference between the smallest value and the largest value. So to go from -2 up 12 places will take you to the maximum value of 10, because the gap between 10 and -2, the largest to the smallest, is a gap of 12. So I can tick that one off. The median was 4. The knowledge you need is, you know, the median is the middle value in an ordered list. Well, our list is ordered, so the middle value is 4. I can tick that one off. The mode was 2. The mode is the most frequent. Well, that means that those 2 there, because it's ordered, have to be 2. I can tick that one off. So that leaves me 2 spaces where I haven't got a temperature. I know that one of them is going to be 5, and that's clearly going to come after 4. So I can tick that one off. Now I'm down to 1 temperature that I don't know. And there's one piece of information here that I haven't used yet, which is the mean temperature for the week was 4. Now the mean is the total, what you get when you add them up, divided by the count, how many there are. So the mean is total, which we don't know, divided by 7. And I know that the mean is 4. When we did reverse means back before half term, we showed you that if the mean is the total divided by the count, you can work out the total by multiplying the mean by the count. And the mean is 4. So that's telling you that all of these temperatures have to add up to 28. Okay, so if they give you the mean, and you know how many days or whatever the data is, by multiplying the mean by the count, how many you got, it tells you the total. So I know these have to add up to 28. Adding up now what we've got there, I've got 10, 15, 19, 21, 23, less 2 is 21, and they've got to add up to 8, so the missing number is 7. Check again. 10, 17, 22, 26, 28, 30, drop 2, 28. So there's 4 marks for that question. And the marks, there's 1 mark for the maximum. Okay, so if you've used the fact that -2 is the smallest and you've got a range of 12, there's 1 mark there for that maximum value. There's a method mark for spotting. You need to find what they all add up to, and an answer mark for recognizing that they've all got to add up to 28. And then the final mark is if you get them all right in the list. Okay? Moving on. So question 4, if you notice at the bottom of question 4, I've put that E in a circle. Right, this was when we did the running total at the start. If we get to the end of question 4 and we've got everything right, we're already grading. So the diagram shows a sail. The top part of the sail is a triangle with perpendicular height x meters. So they're talking about that part there. The bottom part of the sail is a trapezium. Now, as soon as I see that shape, I'm thinking, oh, hang on, I've seen that somewhere before. There it is. Okay, so it's one of the formulas that we're given is related to that trapezium, with a perpendicular height x meters. So that part, the height of the trapezium and the height of the triangle are the same. The area of the triangle is 12 square meters. Calculate the area of the trapezium. So that's what we're being asked to achieve. Now, in order to work out the area of the trapezium, I need to know what the parallel sides are, how long they are, and I do. I know that one is 6 and that one is 14. But I also need to know what that perpendicular height is, and I don't. It's x. I don't know what it is. So before I can answer the question with the trapezium, I've got to somehow get that information on x. And that information from x comes from the fact that with the triangle, they do tell me what the area is. You need to know that the area of a triangle is half times the base, which is 6, times the height, which we don't know. So the area I know is 12, the base I know is 6, and the height I don't know, it's x. So going one more line, I know the area is 12, and I know that half of 6 is 3. So even though it looks like we're setting up an equation, on a numeracy paper it's unlikely or less likely you'll have an equations question. But you can figure this out if you're not sure about equations. 3 times something is 12. Well, the something is 4. 3 times 4 is 12. So x is 4. Once I know that x is 4, I can then work with the area of the trapezium formula. So going back to the formula page, if you haven't learnt it, the area of the trapezium is a half bracket a plus b, which are the parallel sides, so 6 plus 14, and then bracket h. Well, where there's a bracket, it means there's a times there, and the h we now know is 4. Work out the brackets first. 6 and 14 is 20 times 4. Half of 20 is 10 times 4. 10 times 4 is 40. Calculate the area of the trapezium was the question. Area of the trapezium is 40. The units would be meters squared. It's not asking you to give the units, so if you don't lose any marks. So there's 4 marks for that question. The first 2 are for finding what the value of x is. So the method, okay, if all you could do was write that line down, then write it down, because you're going to get a mark for it. And then you get the answer mark for working out 4, and then the second 2 marks, there's the method of plonking your numbers into the formula, and an answer mark for 40. Okay? So we've got ourselves an E, guys. So we're into the grade D work. So let's read this question. Olga wants to paint one side of a garden wall. The wall is 2 meters high and 35 meters long. She has found the following information about special paint that she needs. It is only sold in 5 litre and 2 litre tins. 1 litre is enough to cover an area of 6 square meters. The tins are sold at a price of £12 for a 5 litre tin, so a big tin, and £6 for a 2 litre tin, a smaller tin. Showing all your calculations, find the least amount she has to pay to cover the wall. So that's our instruction. So we need to think now how we're going to do this. We need to know what tins we're going to buy, and in order to do that we need to know how many tins we're going to buy. In order to know how many tins we're going to buy, we need to know what area that wall is. So it's a rectangular wall. Going back to what I said a few minutes ago, areas of a rectangle you would have met in primary school. Area of wall equals length times width, 2 lots of 35, 70 square meters. So that's how much surface I've got to cover with my paint. And so I can tick off that bit of information up there. I've used the diagram to work that area out. 1 litre is enough to cover an area of 6 square meters. So what that's saying is a litre of paint could cover that much maybe, and then I need another litre of paint to cover that much, and another litre of paint to cover that much, and so on. So in order to work out how many litres I need, I'll want to see how many 6s go into 70. So the number of litres needed is going to be 70 divided by 6. And then we're back to primary school, because we're on a non-calculated paper. So we've either got to do a division like that, or you're going to rattle through your times table, your 6 times table. 10 6s are 60, 11 6s are 66, 12 6s are 72. It's going to go, 11 isn't going to be enough, so I'm going to need 12 litres of paint. 12 litres of paint. If we're going to do it on the bus stop, as it's called, 6 goes into 7 once, remainder 1. 6 goes into 10 once, remainder 4. Okay, so it goes in 11 times the remainder, which means I'm going to need 12 litres. So I need 12 litres of paint. So in order to get 12 litres, I'm now in this point here. It is only sold in 5 litre and 2 litre tins. So I'm going to need, or she's going to need, 2 lots of 5 litres and 1 lot of 2 litres. Now I check back, have I answered the question? Showing all your calculations, well, I've done that. Find the least amount she has to pay. Oh, hang on, I haven't done anything with the cost. And this is why it's important with these more detailed questions that you're checking back. I've done a lot of good work there. I haven't done a single thing that's wrong, but I'm not going to get 6 marks because 2 lots of 5 litres is going to cost me £24. 1 lot of 2 litres is going to cost me £6. So to answer the question, the least amount she has to pay is £30. And the reason that's the least is because she could have bought lots of 2 litre tins, okay, but it would have been more expensive. So she could have got the 12 litres by buying 6 2 litre tins, which would have cost her £36. So there were 6 marks for that question. 2 of them were for finding the area. The method mark for correctly doing length times width. Answer mark for 70. Then there was a method mark for 70 divided by 6 for recognizing you had to divide. And an answer mark for 12. And then a method mark for showing the right combination of tins, and an answer mark for the right value of cost, so for getting £30. One thing to say as well is where we've got these method answer marks, if you'd have done a lot of that in your head and got the answer of 30, you get full marks. But the risk you're taking then is that if you got £29 there and the examiner can't see where you've gone wrong, you lose everything. So it's really important that you set your work out carefully. Everybody okay with that? Question 6. And you see at the bottom of question 6, I've got the D in the circle. So going from our running total at the start, if we get this right, and we've got everything else before it right, we're into the grade Ds. So there's a lot of information on this question. And this is the OCW question. This is the question where the 2 out of those 8 marks are for how you communicate, how you set out your maths. Okay? So the more careful you can be in how you lay it out, you're going to get those extra 2 marks, even if the maths you've done isn't great. So Jenny runs a stall at the local farmers market. One week, she made 20 fruit cakes and 15 chocolate cakes to sell on the stall. She planned to sell the fruit cakes at £6 each and the chocolate cakes at £2 each. The cost of making each type of cake was half of the normal selling price. She sold 3/4 of the fruit cakes at full price and decided to sell the rest of them at 70% of the normal selling price. She sold 13 of the chocolate cakes at full price and the rest at half price. How much profit did Jenny make? You must show all your working. So in all of that information, that's what the question is. And we've done quite a lot of these profit questions, loss questions, in the progress check so far. So hopefully that triggers for you. I need to separate this out into money that's going to come in and money that's going to go out. Money that's going to go out is what I have to spend, or what Jenny has to spend on the ingredients to make the cakes, and the money that comes in is what she's going to be paid by the people that want to buy the cakes. So let's work with the cost of the cakes first of all. Okay, so I'm going to put a little head in there, cost of cakes. And we've got 2 different types of cake. We've got the fruit cake, so let's work with that. And the fruit cake, the cost of making each type of cake was half of the normal selling price. So we're using this line here. So the fruit cake, she sells for £6 and so it's going to cost her £3 to make. And she's making 20 of them. So 20 lots of 3. The fruit cake's going to cost us £60. Then we've got the chocolate cake. The chocolate cake is going to cost her half of £2, so £1 to make. And she's making 15 of those. So in order to make her cakes, it's going to cost her £75. So if whatever she sells them from is going to be less than £75, she's making a loss. Yeah? So that's the cost of the cakes. Then we're going to work out her income. So the income from selling. So the selling information is here. So first of all, this is about the fruit cakes. she sold 3/4 of the fruitcakes at full price. So 3/4 of 20. Well, 1/4, you're going to divide by 5. Sorry, no you're not. You divide by 4 and get 5. So 1/4 is 5. So 3/4 is 15 cakes. So she's going to sell 15 cakes at full price. Okay, so 15 cakes at full price, which is £6 each. Back to primary school. 15 times 6. 5 6s are 30. 0 down, carry 3. 1 6 is 6. And 3 is 9. So that's going to be £90. So she's going to sell 3/4 at full price. She's going to get £90 for. And the remaining at 70% of the normal selling price. So the cakes that are left which are going to be 5 cakes, the normal selling price, which is £6. This is a monster of a question, this one is. Without a calculator, when you're trying to find 70% of something, the first thing you would do is find 10%. When you're trying to find 10% of £6, it's easier if you find 10% of 600 pence. Because 10% you're going to divide by 10 will be 60 pence. So 70% will be 60 times 7, which is 420 pence, which then we could put back into pounds, which is £4.20. So these 5 cakes she's going to sell, she's actually selling at £4.20 each. So back to primary school, £4.20 times 5. 5 zeros are 0. 5 2s are 10, put the 0 down, carry the 1. 4 5s are 20, and 1 is 21. So that's going to be £21. So those fruit cakes, what was in her head, what she was thinking of when she decided to sell them that way, goodness only knows, but that's what she's selling them for. 15 of them she's going to sell for £90, and the remaining 5 for £21. Then we've got chocolate cakes. She sold 13 of the chocolate cakes at full price, which is £2 each. So she get £26 for those, and the rest at half price. So the rest of them at half price. So she started with 15, she sold 13, so she's got another 2 to sell at half price. So her total income will be £90 for the fruitcakes, plus another £21 for the fruitcakes, plus a £26 for the chocolate, and £2 for the remaining chocolate. So we've got 90, and here we've got 47, 49, so that's going to be £139 in. Have I answered the question? How much profit did Jenny make? I haven't answered it yet. I know that she got paid £139 for selling them, and I know that the ingredients cost her £75. So her profit will be 139 less 75. Now whatever subtraction method works for you is fine, whether you're going to do counting on or whether you're going to do it columns like this. So 5 take away 9 is 4. 7 take away 3 you can't do, so you have to move from the next column. And 7 from 13 is 6. So the profit is £64. That is a horrible question. It's worth 8 marks though. 6 of those marks are for the maths. One of them is for £75. Okay, so there's a mark there if the examiner is seeing 75. So even if that's all you can do, don't not do it, write it down. So that's 75. Then there's a mark for the £90. A mark down here for the £28 for the chocolate cake. And then a method for finding the profit, difference between outgoings and income, and an answer for £64. Then, and you'll see this when we mark your work, then we say OCW plus. And that plus can either be a 0, a 1 or a 2. It's a 0 if the page is chaos. It's a 1 if the examiner can see what you're trying to do. So we're not asking you to write a story, we're asking you to lay it out like I've done there. So we've separated outgoings and income, and if I'm working with fruitcakes, I'm writing fruitcakes. If I'm working with chocolate, I'm writing chocolate. That'll get you the +1. And then the +2 is for consistently how you use units. So when I'm talking with money, I've got pound signs or pence signs. So it's being consistent in your units will get you those extra 2 marks. Okay, so there's a lot to deal with there. If you didn't follow it, I suggest you watch the video over the weekend. Okay, so we're into the grade C questions. Question 7. A map below shows the island of Mallorca. Find the bearing of Palma from Alcudia. Will do. Right, so bearings, it's a trigger. We've done bearings this week, so hopefully this is fresh in your mind. The key instruction is where you're going to put your measurer when you start. You're finding the bearing of Palma from Alcudia. So that means that's where you are. You're standing in Alcudia. So your measurer is going to go on Alcudia. But before we put the measurer on, it's going to help us if we join the 2 places that we're talking about together with a line. So we're going to join them together. We've correctly realized we need to put the measurer on Alcudia because that's where we are. and we line the 0 up with north. Okay, so the center of the measurer is on the town, the 0 lines up with north. And the learning that you have to do with bearings is that the angle is measured in a clockwise direction. So when we turn, we always turn clockwise. And we need to turn until our line of sight goes from north until it's looking at Palmer. The other problem with one of these measurers is we've got two scales. We want to count from 0. So we're not going to use the blue scale because that jumps from 0 to 350. We're going 0, 10, 20, 30, 40, 50, all the way around until we reach the line for Palmer. And that's going to be 220, 225 degrees. And you need to make that as accurate as you can. The examiners will allow you a small margin of error. So if you've got 234 or 236, you'd be okay. Arta is another place on the island of Majorca. Arta is on a bearing of 073 from Palmer and on a bearing of 130 from Alcudia. Indicate where Arta is on the above map. So there's your instruction. Okay, so we're going to start off from Palmer. From Palmer, we've got a bearing of 73 degrees. So we put our measurer on Palmer. We line the 0 up with north. And we want 73 degrees. So 0 around, find your 73 degrees, mark a dot, and draw a line from Palmer, take it through the dot. Don't stop at the dot, extend it through the island. We know this village is there somewhere on that line. In order to find it, we've got to use the second bearing, which is 130 from Alcudia. So we've got to go back to Alcudia, put our measurer on Alcudia, and measure 130 degrees clockwise, mark a dot, and draw the line from Alcudia and where the two lines cross is where Arta is. So hopefully, if you've had a chance to do it, that's where yours is as well. So that's some bearings work. Part C. The distance between Alcudia and Palmer is 54 kilometers. Write down the scale of the map, so there's our instruction, in the form 1 to something. So map scales covered in the last couple of weeks. So the first thing we need to do is measure on our map how far the distance is in centimeters. So when we measure that, it's 6 centimeters. So 6 centimeters on the map. So on this side we've got the map, which is 6 centimeters, and on this side we've got the actual distance, which we know is 54 kilometers. So 6 centimeters on the map, 54 kilometers in real life. And what we have to do is to get it down to the point where we don't have any units. And on the left hand side, we want 1. Well, that's the first step. That's quite straightforward. Because in order to turn 6 centimeters into 1 centimeter, I'm going to divide by 6. Because 6 divided by 6 is 1. And with ratios, in order to keep the ratio, whatever you do to one part of it, you have to do it to all the other bits as well. So if I'm dividing the left-hand side by 6, I've got to divide the right-hand side by 6 as well to get 9 kilometers. So 1 centimeter on the map is equivalent to 9 kilometers in real life. The next thing I need to do now is to turn this kilometers into centimeters so it's the same units on both sides. I know that there are 1,000 meters in a kilometer. So if I times that by 1,000, it gives me that 1 centimeter on the page, on the map, is the same as 9,000 meters in real life. I don't want it in meters, I want it in centimeters. I also know that there are 100 centimeters in a meter. So if I times that by 100, I get 1 centimeter on the page, on the map, is 9,000 with another 2 zeros added to it, centimeters. And once I've got centimeters and centimeters on both sides, I don't need to write the units anymore. So then I can just write it as 1 colon 9 followed by 5 zeros, which is the answer. Okay, marks for that. They're looking for 1 mark for 225 degrees. If you got 224 or 226, you get the mark. For part B, you've got 1 mark for drawing the line from Palmer. So there's 1 mark for that blue line. Sorry, you can't see it. There's 1 mark for that blue line, and there's 1 mark for the line from Alcudia, and then there's a final mark for pointing out that where the 2 lines cross is where the village is. So there's 3 marks for that, and then for the final nasty bit, there's 1 mark for just writing down that you've measured it from the graph. So if the only thing you could do was measure it in centimeters and write what that is the same as in kilometers, you've got a mark. Then there's 1 mark for getting 1 is equivalent to. So 1 centimeter to 9 or 1 centimeter to 9,000. And then the final mark is for finishing it off where you've lost all your units. Intermediate tier students don't like map scales. Quite happy with bearings. So I would imagine lots of you would have been happy with those first 4 marks, but not so happy with those 3. But all of you could have done that first line and got 1 out of 3. Question 7D. And at the bottom of 7D, I'll need to zoom out. You see I've written the grade C. So this is the 40 mark boundary. If we've got everything right up to here, we're on to C's. Okay, a new runway site is being planned for a different island. A diagram of the plan for the runway is shown below. Right, I'm seeing straight away this bit of information. Diagram not drawn to scale, okay? So that means you can't use this. It's not a measuring question. Parallel lines means there are angle properties. You've got a triangle there and you've got parallel lines. With your parallel lines, the easiest ones to spot are the Z angles. Okay, so the Z angles are the ones that go like that. Okay, that's telling you if that's 72, that's 72 there as well. And then you've got another set of parallel lines here, which means so you've got more Z's there. Now the other really useful property with parallel lines is the opposite angles. Where you've got two straight lines that cross, I know that if that's 72, opposite is 72 as well. So that's 72. If that's 72, that's 72. And if that's 72, so is that. So those 72s are all over the place. And by putting those in, I haven't even looked yet at what I've got to figure out, but I've already found y is 72. When I'm looking at x, I've got a straight line. I've got a few straight lines, it doesn't matter which one you deal with, but if I put my ruler across there, I can see that x and 72 lie on a straight line. So another angle property that you need to know is that angles on a straight line add up to 180. So to work out what that one is, I need to take 72 away from 180 and get 108. Now, although these aren't drawn to scale, they look about right. So the 72 is an acute angle, that one is an obtuse angle, so it's bigger than 90, and I've worked it out to be bigger than 90. So I'm quite confident that that's right. If I'd have worked that out to be 36, something would have been wrong. So I've worked out x and I've worked out y. To find z, z's all the way over here, and it's not part of any of that set of parallel lines. So I'm not going to be able to use parallel line properties to figure that out. But what I do see, if I bring it out onto the page and do this in the exam, if it helps you to clear the rubbish away. In this big triangle, I know that the top angle is 90, and I've worked out that y is 72. So I've only got one unknown in that triangle, which is z. Another angle property you need to know is that angles in a triangle add up to 180. So 90 and 72 is 162. So z is going to be 180 less 162. Using whatever method you've got for subtracting, whether you're counting on or whether you're going to do it in columns. If you're going to do it in columns, you need to make that a 10. So you'll have 8, 1, and you'll have 18 degrees. There's 4 marks for that question. There's 1 mark for the 108, 1 mark for the 72, but there's 2 marks for the last bit. One is a method for working with triangles, and one is the answer. So when you see parallel line questions that are not drawn to scale, start spotting these opposite angles and the z angles and write them on your diagram, because they'll help open up other things that you'll be able to spot. Okay, so we're into beyond grade C now, because we've got our grade C. Question 8. Agnes and Bryn both buy identical pizzas to share with friends. Agnes gives Carwyn 2/5 of her pizza. Bryn shares his pizza in a ratio of 1 to 2 to 3 to 4 and gives David the largest piece. Does Carwyn have the same size piece of pizza, or a larger piece of pizza, or a smaller pizza than David? You must explain your answer and show all your working. So I'm clear how much of the pizza Carwyn is going to get. So Carwyn gets 2/5. I've got a bit more work to do with David. So for David, we've got the ratio of 1 to 2 to 3 to 4. And the piece that David gets is the largest piece. So this bit here is David. When you work with ratio, to find the number of equal slices, equal parts we're going to divide this into, we add those parts up. So we've got 4, 7, 9, 10. 10 parts. And that means as a fraction, this divides up into 1/10, 2/10, 3/10, and David's share is 4/10. So it's whatever the number is in the ratio over the number of parts. So David gets 4/10 of pizza. So Carwyn gets 2/5. David 4/10. So what we need to do now to answer the question is compare these two fractions. And to compare the two fractions, the easiest thing to do is to double the size of this fraction. 2 times gives us 4/10. So Carwyn gets 4/10 of Agnes's pizza, and David gets 4/10 of Bryn's pizza, so they end up with the same amount. So the marks for that, there's a method mark for finding the 4/10 that David gets, and then there's an answer mark for making the fractions equivalent, and an answer mark for saying they are the same. So 3-mark question. Question 9. During the year, both Lara and Glyn paid for new bikes. The costs of the bikes are given below. Lara bought the Lex 8E and Glyn bought the Harrier. So Lara bought that one and Glyn bought that one. Then we've got different payment methods. So Lara paid a single payment of £125 plus 11 monthly payments of £23. Glyn made payments in a given ratio, of which the largest payment is 248. Who paid more for their new bike and by how much? You must show your working. So let's start with Lara. So she paid a single payment of £125 plus 11 monthly payments of 23. So one way or another, you've got to figure out what 11 lots of 23 is. So you could do 10 lots is 230 plus another 23. You might know the shortcut for multiplying by 11, which is to add the two digits together and stick it in the middle to 253. Or just in case, let's do it the way that many of you are comfortable with, which is as a multiplication. So whatever method you use, it's important that you can get this right. So you draw your grid and your diagonals run through the corners. Then you do 1 times 2, which is 0, 2, 1 times 3, 1 times 2, 1 times 3. So that's how you fill in, and then you add up the diagonals. So in this diagonal it's just 3, then we get 5, then we get 2. And reading in that direction gives us the 253. Really doesn't matter what method you have for multiplying, but it's so important that you have a method that works. So don't bother copying that. If you think, oh, I wouldn't do it that way, great. Put down what method you use. So for Lara, she's going to pay £253 plus 125. So her bike's going to cost her £378. Then we come to Glyn. Glyn is paying in the ratio 2 to 5 to 8. And this type of ratio question, they're giving you what the largest payment is. And you need to work out what the other ones are. And in order to do that, just like with that map scale question, we need to work out what has happened to the 8 to get to 248. So it's been multiplied because it's grown, it's larger. So back to the arithmetic. In order to find out how many times bigger it is, I need to see how many times 8 goes into 248. 8 into 2 doesn't go. 8 into 24 does, goes 3 times with no remainder. 8 into 8 goes once. So the multiplier is actually times 31. Everything is 31 times bigger. So the 2 becomes 31 times bigger, which is 62. The 5 becomes 31 times bigger. Over here I'm going to do a non-calculator multiplication of 31 times 5. 5 times 1 is 5. 5 threes are 15. So that's 155. So Glyn's payments are going to be £62, then 155, then 248. So total 62, 155, 248. Here I am back in primary school. Column addition. 8 and 5 is 13 and 2 is 15. 1, 5, 10, 16. 465 pounds. Have I answered the question? Who paid more for their new bike and by how much? No. All I've done is I've worked out that Lara paid 378 and Glyn paid 465. So Glyn paid more. And by how much? I've got a subtraction to do. Can't take 8 from 5. 8 from 15 is 7. Can't take 7 from 5. 7 from 15 is 8. So Glyn paid £87 more. Now I've answered the question. Glyn by £87. Okay, marks for that. There's 2 marks for just working out Lara's. So going back to what I've been saying, even if you don't think you can answer it all, you can make progress. So there was a method mark and an answer mark for 378 quid. There's a method mark for finding out what the multiplier is in the ratio. So finding the times 31. And there's an answer mark for the £465 and an answer mark for the conclusion, 245, and there's an answer mark for working out those there, the individual parts. So now we're into grade B, and I know it's freezing cold in here. I'm freezing sitting up here, but we'll get through this in the next 20 minutes. Okay, so question 10. When Fisher Tours takes a coach trip to the zoo, they must follow instructions for parking. An accurate scale drawing of the entire coach parking zone at the zoo is shown below. Fisher Tours has been allocated a parking area within this parking zone. The instructions for parking are as follows. Must be further than 12 meters away from a point A at the ice cream kiosk. Must be closer to the lamppost Q than the lamppost P. Indicate on the scale drawing above the region in which Fisher Tours can park their coach. So that's what we have to do. I'm hoping reading this and recognizing we're in the grade B section now is making you think, right, this is loci. We've got a scale. So this is one we can measure. Must be closer than 12 meters away from point A. So the loci is equal distance from a fixed point. 12 meters, using a scale of 1 centimeter to be 4 meters, that's going to be 12 divided by 4, 3 centimeters. So this now is where you need to get your compass and you need to open it out to be exactly 3 centimeters. So put your compass point on the 0 on the ruler, measure it to 3, put the compass point at A and draw your circle. So that's the first instruction. And the parking has to be further than 12 meters. So it's going to be outside that circle, but we won't shade it yet. Then for the second one, it must be closer to the lamppost Q than to the lamppost P. So I've got to have the dividing line between those 2 points in order to know which one is closest to. That's another loci where you have to draw the perpendicular bisector. So we did this way back in early September. So you need to check back through your notes if you can't remember how to do this. You need to take your compass and open it out so it's visibly over halfway. You don't have to measure it, but by eye it's got to be over halfway. You put the compass point on P and draw yourself part of a circle. Then without changing the size, you put the compass point on Q and draw part of a circle to make sure that they cross the previous circle that you drew. And then you join and draw your line right the way through the diagram. Okay, so for the last mark we get a shade. Indicate on the scale drawing above the region in which Fisher Tours can park their coach. So it's going to be closer to Q than to P. So it's going to be below the bisector line that we've drawn and further than 12 from A. So So it's below the line and outside the circle. So you need to make sure they can clearly see where you're shading. 3 marks for that, 1 for the circle, 1 for the perpendicular bisector, and 1 for the region. Okay, question 11. So we're solidly into grade B now for the last couple of questions. A broadcasting company, Stateside 3, investigated television viewing habits. The table below shows the number of minutes 80 people spent watching television last Wednesday. Did any of these people spend longer than 15 hours watching television last Wednesday? Give a reason for your answer. So when we teach this, when you've done this in class, what we always tell you to do is to pick a line in your table and turn it into a sentence so you understand the context. So the context of this is how long in minutes 80 people spent watching television last Wednesday. And this line is saying 20 people spent between 180 and 270 minutes watching TV last Wednesday. So that's what that is telling you. Did any of these people spend longer than 15 hours? Well, in order to answer that, I need to know how many minutes there are in 15 hours. So I've got to do 15 times 60. Well, if I do 15 times 6, that's 90. So times 60 will be 900 minutes. So 900 minutes is 15 hours. The table is telling you it only goes up to 810. So to answer this, I'm going to say no, because no one spent longer than 810 minutes. And because I've shown there that 15 hours is actually 900 minutes, that satisfies that question. If they don't see that you've worked that out in minutes, you haven't done enough. Part 2. Complete the following cumulative frequency table. Now, usually in numeracy, you are given the cumulative frequency graph. In this particular question, we're going to have to draw that ourselves. So the way that the cumulative frequency table works, and when we introduced cumulative frequency back in September, we did this to do with dart throwing, if I remember. So the number of people that spent less than 90 minutes watching TV is 10. So I'm going to write a 10 in there. When it comes to less than 180, well, less than 180 takes me here. So it's those 10 and those 38. So 48 is going to go in that box. For less than 270, which is taking me to there in the table, it's those 10 and those 38, which is 48, and those 20, which is 68. To get to 450, I've got all of the ones above it, which is 68, and another 8, which is 76. And finally, adding the last 4 in, I get 80. And that figure there should always come to the total number of people, or whatever the context is that you're given. On the graph over leaf, draw a cumulative frequency diagram to show this information. Okay, so this isn't going to fit. Oh, it's not bad. So when we plot this, we start off at 90. Check the units of our scale here. We're going from 0 to 100 in 10 jumps, so each square is 10. So on 90, we've got 10 people. So I'm going to cross to 90 and up to 10. Then I'm going to 180. 180 is going to be 2 squares in from 200. Use a long ruler, it helps. And that's 48. Put across. 270 is going to be 3 squares in. And that's 68. $450 is 76, and 810 is 80. So your points are going to look like that, and you can join those with a ruler. You could draw them freehand, but it's easier to use a ruler. Up until a few years back, that was a really common question to get you to draw the cumulative frequency diagram. More recently, it hasn't come up. That's not to say that it won't. So it is important that we practice it, but more often than not now, they're not asking you to draw it. Part 5. Use your cumulative frequency diagram to find an estimate for the median and interquartile range of the times spent watching television last Wednesday. So when you're talking about cumulative frequency, your brain should be linking them with median, upper quartiles, lower quartiles. The median is the middle of the data. We've got 80 sets of data, so the middle is 40. Just like before, mark it on your graph. So this is the median. Reading that off the graph on mine, I've got 10, 20, 30, 40, 50, 160. If yours is 1 square out, they'll accept that. So the median is 160. Then, to find the interquartile range, we need the upper quartile and the lower quartile. The lower one is at a quarter of the data, so it's halfway between 0 and the median, which is 20. So we go to 20, read down, and that's going to be on mine 110, and the upper is going to be halfway between the median and the top, which is going to be 60. Which for me works out to be 230. The interquartile range you get by subtracting those. So 120. So the marks for this you're going to have one mark for your explanation there, one mark for filling in the table. On the graph there's one P mark for plotting it and a line mark for joining them together, and down here you're going to have a B mark for the 160 and an M and an A mark for the interquartile range. Now I'm going to stop here because we need to clear in time for break, so I'll finish this off. When I upload the video later, I'll upload a second part of the video which will have the final questions on. If I want to set you homework for this weekend, can I please ask you, in particular those of you that are aiming for B's and C's, to watch the second clip which has just got the last couple of questions on it.